Okay, so polar coordinate again, instead of an X and a Y, we're going to have an R, which is like a magnitude, a distance to the origin. You can also think of R like a radius of a circle. And theta is a rotation. The rotation starts like we are used to on the positive side of the x-axis, and we rotate counterclockwise if it's positive, and we rotate clockwise if it's negative. We have a few new names for things now. Instead of an origin, it's called a pole. And instead of an x-axis, it's called a polar axis. So that's a good little picture to draw, that little angle there. That looks like. Okay, so the point, R, theta, are the coordinates now. Instead of an X and a Y, you have an R, radius of the circle, distance to the origin, theta. And instead of an origin, you have a pole. And instead of a x-axis, you have a polar axis. Too far. There we go. Okay. You don't have to draw anything at the bottom here. X, Y coordinates are unique. If I tell you the point 2, 3, that is the only way to get to that point. You go 2 to the right and 3 up, and that's it. Polar coordinates, though, because they deal with rotations, are not unique. I can change the rotation. I can still have the exact same point. And this is just like when we talked about coterminal angles with our unit circle, right? We can add or subtract the full 360 degrees, and it's still at the same spot on our unit circle. Same is true for polar coordinates. I can describe a point maybe as like 360 and 3 units from the origin and 60-degree rotation. But that 60-degree rotation is the same as a 420-degree rotation. It's going to take me to the same spot. Or if I subtract 360, I can say 3 negative 300. That would also be a way to name that polar coordinate. Okay. I wonder if I have some polar graph. Hold on one second. If not, you're just going to have to draw some circles. Tree graph paper, pencil graph paper. Nope, I don't have it. All right, well, it is what it is. We'll deal with it. Okay. Draw 4 circles inside each other on your paper. Okay, so a little circle and then 3 bigger circles. And then within those circles, we're going to put X and Y axes. Okay, so something like that. Okay. So 4 circles and then a little axes through the middle. All right, we're going to graph a couple points on this picture. I'm going to actually graph point A first. We're going to call point A 4, 240 degrees. Here's how you would graph it. 4 means I am 4 units away from the pole, away from the center, away from the origin. If I'm 4 units away, I'm on the 4th circle out. Okay? So I know on that 4th circle, my point is going to be somewhere. Then 240 degrees tells me where I'm going to stop that rotation at. And you can just picture where 240 degrees is going to be on your unit circle. What quadrant is that in? It's in quadrant 3. So 240, 4 circles out, I have 5 circles on my picture, will be there. That's that point. Okay. Let's do another one. Let's say I have 0 and 10 degrees. What does the 0 tell me? I'm 0 unit circle, 0 units from the origin. So does it matter what the degree is? If I'm 0 units from the origin, I'm at the origin. There's B. Okay. What if I had 3 and negative pi over 3? Okay, so 3 tells me I'm 3 circles out, yeah? And then where's negative pi over 3? That's negative how many degrees? Negative 60 degrees. Negative pi over 3, negative 60 degrees. I would rotate 60 degrees clockwise. That would be right about there. Okay. If you have a negative angle, and it's written on the side there, we're going to call it point D, negative 4, 240 degrees. Not a negative angle, a negative R value, I should have said. It's a little bit different. If the R is negative, you're still 4 units out. You're still going to be on the 4th circle, but we're not going to start on this side of the polar axis. We're going to start on this side of the polar axis. Okay, so 4 units out, instead of starting here, I'm going to actually start over here. And then from there, that's where my rotation goes. So from this point, that's where I need to rotate positive 240 degrees. If I'm rotating positive 240 degrees, am I going clockwise or counterclockwise? Counterclockwise, okay? So from there, I would have to rotate 90, 180, how many more degrees? Another 60 degrees, it's gonna place me right there. That's point D. And you can see how A and D are related to each other. I actually could have graphed it with the positive value and then just did a 180-degree turn if I wanted to, or just go backwards across that like little ray that you see there. That's another way to graph it. But I like to think of it as you either start on the right if it's a positive R, or you start on the left if it's a negative R. Okay. Draw another picture, and with a friend, see if you can plot all these points. And then we'll put them up on the board. Okay, here's my answers. Those are pretty good. What do we need to adjust here? D, I'll give you D. That's okay. That was just an estimation. E, we're just 1 ray off. I think E rotated a little. Oh no, maybe I did. Hold on. What was the angle on that? I wrote that one wrong. I'm wrong. E's right. We're okay. I can't count. F.
Yeah.
We need to.
Last one was negative, and then so I thought you started like the counterclockwise.
You do. You start there. You start 3 to the left, and then it's a negative rotation also. So you have to rotate clockwise 30 degrees. So imagine if I'm on the right there, and I'm going to go the way a clock's going to go, I would have to go up 30 degrees.
I literally was just starting at the, well, I was just doing it all wrong. I was starting at the origin, and then, but like instead of going left, like counterclockwise, I went clockwise to 30, and then went 3 out. Not like 3 out, then the other.
I see. Okay, does that make sense?
Yeah.
Okay, got it. All right. Any questions graphing these? Okay, so now I want you to graph one more on that same paper. Call it like, I don't know, what letter are we on? H. To negative 150 degrees. Okay, so how would I graph that? To negative 150 degrees. What would I do? To which direction? To the right. Okay, and then from there, do I go clockwise or counterclockwise? Clockwise, 150 degrees. And these rays, when you have polar graph paper in front of you, I'll get you guys some tomorrow. They're every 30 degrees, these little rays. So you can just count 30, 60, 90, 180, or 180, 120, 150. There we go. That's the point. H. Okay, got it. Good? Okay, so now, next part of the question. We need to write another set of coordinates that'll get it to that same point, okay? And they're specific about how you want to write the coordinates. In the first one, we want R to be negative, and we want theta to be a positive angle between 0 and 360. Okay, so R is negative, theta is positive. Okay, if I want to get to point H, you don't really have a whole lot of options for R. You're on this, bless you, you're on the second circle out. So your R is either a positive 2 or a negative 2. We want R to be negative 2. We want it to be negative in this case. Okay, so now we got to figure out, my r is -2. I have gone 2 spaces to the left. I want a positive rotation that'll get me to there. How much do I have to rotate counterclockwise, positive rotation, to get to my point? How much? 30 degrees, that's it. Okay, that's another way to get to that coordinate. Okay, let's do another one. This time I want r to be negative, okay, but I want my theta to also be negative. Okay, what's my only choice for r? -2. Okay, so again, I'm going to start, we're going to graph my new point by going to the left. But this time I want a negative rotation. So I want to go clockwise. How much do I have to rotate clockwise to get to h? 330 degrees. Negative 330 degrees. Okay. Let's say I want r to be positive this time. So what's my only option for r? 2. And I also want a positive theta. Okay, so if r is +2, I'm going to go 2 to the right. And now I want a positive rotation, so clockwise or counterclockwise? Counterclockwise. How much do I have to rotate to get to h? 210. There are formulas and things you can use for questions like this, and that's what Math Excel is going to use if you try to look at the help me solve this. It's a whole lot easier just to sketch the point and imagine the rotation rather than trying to do the calculations with the theta you have to get the new theta you want, that sort of thing. Okay, any questions? No. Good. Okay, the last thing we're going to do in this lesson, I need you to write down these 4 formulas that are highlighted. Okay, these 4 formulas allow us to convert from r's and thetas to x's and y's or vice versa. Okay, so write them all down. They all come from the Pythagorean theorem, or you can see we've got our little right triangle here. All of our right triangle ratios for sine, cosine, and tangent can be manipulated, calling our hypotenuse r, and get these new little formulas. So nothing like groundbreaking here with these. Ooh, I left the piece. Get rid of that. The one that looks like a Pythagorean theorem, you can even take one step further and take the square root of both sides and say the square root of x squared plus y squared equals r. These formulas, I think, make it obvious why we do this right after vectors. Do you guys recognize that's just our magnitude formula we were talking with vectors, the square root of x squared plus y squared, and r sine and r cosine, we had magnitude times sine of an angle, magnitude times cosine of an angle when we were writing our vectors. That was one of our vector formulas. And x goes with cosine and y goes with sine, just like our unit circle. So you're going to see a lot of like overlapping ideas. We even used that tangent formula when we did our vectors and we were trying to find the bearing of some of those problems. So this is all kind of just another context, another way that we can use the same sort of stuff. All right, so let's do an example. Let's say I want to convert the following polar coordinates to rectangular coordinates. If I'm told they are polar, I have an r and a theta. Okay, and it could be a degree, it could be a radian. Your job to convert to rectangular coordinates is solve for the x and the y. And you have formulas that you just wrote down for x and y. X is our cosine, easy to remember, we know x goes with cosine from our unit circle. Y is our sine. Plug it in. -3 cosine 60. What is the cosine of 60 from your unit circle? 1/2. So I get -3/2 is my x coordinate. R sine, -3 sine 60 equals -3 times what's the sine of 60? Rad 3/2. And I get -3 rad 3/2. So that coordinate, -360, if I graph it on a polar graph with all the circles, I will see it in the same position as if I graphed this point on just an XY plane. you can kind of imagine both of these would be in quadrant 3 if I graph them. The x and y are both negative. That places me in quadrant 3. -3, that would be 3 to the left. If I'm looking at the polar coordinate, 60-degree rotation would be down into quadrant 3. You can imagine we should be in the same position if you're doing them right. Just superimposing one type of graph on top of another. Okay, let's look at the next one. Same sort of scenario. I need to do r cosine and r sine. If I do r cosine, it's going to look like 2 cosine negative pi over 4. It is helpful to remember your even-odd identities. Do you remember if cosine's even or odd? It's even, which means what can I do with that negative? I can just drop it and find the cosine of pi over 4, which is what? Rad 2 over 2. Times 2 is just rad 2. And if I do r sine, I get 2 times the sine of negative pi over 4. Is sine positive or negative? Or positive or negative, even or odd? Sorry. It's odd, so what do I do with that negative? If it's odd, I bring it out front. And then what's the sine of just positive pi over 4? Rad 2 over 2. 2's cancel again, negative rad 2. Final answer is rad 2, negative rad 2. Both of these, if you graph them, would be in quadrant 4. So it's a quick little mental check that you can do to make sure you've done it correctly. Tomorrow, we'll convert the other way, and then we're going to look at some polar graphs. All right, do you guys have your graphing calculators? Grab them real quick. We're going to put your graphing calculator in a certain mode to be able to do this activity. Okay. There we go. Okay, so your homework tonight is to just literally sketch things off of your graphing calculator and say what you notice. What patterns do you see? And then we're going to talk about it in the notes tomorrow. It's going to take you about maybe 15, 20 minutes at most. You're not graphing things by hand, you're just sketching a picture off the calculator. Okay, don't panic. All right. So on your calculator, let me get mine loaded up. It says this in the top corner of your paper, but it can be a little confusing, so we'll just do it together. First thing I want you to do is hit mode in the calculator. I'm in a weird thing right now, apparently. Are you sure? Yes. Quit. Are you sure? Yes. Come on. There we go. Hit mode. We are currently in function mode. That's another word for rectangular mode. That's how you've always graphed things. We want to go to polar mode now. Okay, so it's like the 4th line down. Find polar and hit enter. Okay. Now when you go to y equals, it's not going to be y's anymore. It's going to be r's. When we graph in the graphing calculator, your r needs to be alone. So you'll notice on the packet, all of the r's are alone already for you, okay? And if you hit the x button next to alpha, an x won't show up anymore. It's going to be a theta. That's the other variable. So it's just changing our variables. Instead of x's and y's, we're going to see r's and thetas. So that's how you type a theta. My plot's on, so I'm going to turn it off. Just make sure your plot's not on. Okay. Then the next thing it says, go into window, and we're going to change these values to match what you see on your packet. Okay? And this is, again, on the top right corner there. So theta min, you're going to put a 0. Theta max, we're going to put 720. Theta step, we're going to put a 5. So we're telling the calculator just graph between 0 and 720 degrees, graph every 5 degrees. The x and the y values are all going to be the same. So x min, we're going to use -6. X max, we're going to use 6. X scale, we're going to use 1. Y min, -6. Y max, 6. Y scale, 1. Other mode we need to check, which I should have done when we were in mode, is we need to be in degree mode for this. So mode, I'm not. Double check that you're in degree mode. Okay, so degree in polar mode. And again, the window settings look like this. Everybody have it in there okay? All right. So now, go back to your y equals, which is now an r equals. And we're going to just type 3 sine theta. 3 sine x. The x button, you see a theta pop up. Now hit graph. And there's our graph. Is it not working, guys? Everybody okay? It's okay. All right, now remember our screen is rectangular, so it's pulled a little bit. This looks like an oval, but because our screen is rectangular, that's why it looks like an oval. This is actually a circle. So here's how you would graph it on this picture, okay? So you're gonna make a point at the origin, and then just count the tick marks. 3 tick marks up is the top of that circle. So you're gonna make a point 3 units up on the y-axis, and then you're just gonna connect it and draw a little circle, and that's it. And you're gonna do that 6 times, and then you're gonna answer questions about what do you notice? What happens if the number gets bigger, or the number gets smaller, or if it's a sine or a cosine, and then see what you can do. Okay, and you do this 3 times on the packet. Graph a certain set of questions. What do you notice? Graph a set of questions. What do you notice? And then on the back, do what you can without graphing, but if you get stuck, you can graph it in your calculator to And that's it. Okay? Let me help you, and then I'll help you. Yeah, I'll just help with one on the second too, guys. Yeah. Yeah. Okay. Probably your window, either your window or your nose. And scroll it down. There you go. Okay. It was weird. All right, finish that for tomorrow. I am going to check it tomorrow for a completion grade. I'm going to come around and you're going to flip through and you're going to tell me you did it.
I have like this big structure. I don't know. Like it's really tight in there. I had it for a while. I want to get there.
Okay, let's see. Format.
If not,
I think we can change it there. Background. I hit format at the top. Background. Those are different images. Colors. White. There, that looks normal. Okay. All right, all good?